This presentation regards the construction of simple Lewis structures. This presentation deals only with the construction of octet conforming structures. More advanced concepts dealing with octet rule violations, resonance, and formal charge will be considered in later presentations. Users of this presentation are expected to already have some knowledge of Lewis structures from classroom work and reading the appropriate sections of a chemistry textbook. This presentation is designed to reinforce proper techniques for constructing Lewis structures. The total number of electrons in an atom is equal to the atom's atomic number. Only the valence electrons of an atom are directly involved in forming bonds and lone pairs in a Lewis structure. The number of valence electrons is equal to the group number for groups 1 to 12 and is equal to the group number minus 10 for groups 13 to 18. In older periodic table labeling, the number of valence electrons is equal to the value of the Roman numeral used to label the groups. The groups 9 to 12 are an exception, where the Roman numeral and the number of valence electrons are not trivially related. The first example will be the Lewis structure of tetrachloromethane molecule. The first step in constructing a Lewis structure is properly counting the number of valence electrons in the molecule. The group number of carbon is 14, meaning each carbon contains 4 valence electrons. The group number of chlorine is 17, meaning each chlorine atom contains 7 valence electrons. There is 1 carbon atom donating 4 valence electrons and 4 chlorine atoms each donating 7 valence electrons. This results in a total of 32 electrons that must be represented in the final Lewis structure of this compound. The second step is determine the central atom of the structure. With the exception of hydrogen, the atom with the lowest electronegativity will be assigned as the central atom. Atoms of higher electronegativity will be assigned as terminal atoms. In all cases, hydrogen is assigned as a terminal atom regardless of the electronegativity of any other atom in the structure. In this case, the electronegativity of the chlorine atoms is 3.16 and the carbon atom is 2.55. Thus, the carbon atom will be the central atom in this molecule. The third step is to form a skeletal structure by bonding each of the terminal atoms to the central atom. A bond contains 1 pair of electrons shown as a single line between the central and a terminal atom. The electrons used in forming the skeletal structure should be subtracted from the total number of valence electrons in the structure. The fourth step is to distribute the remaining electrons in pairs symmetrically to the terminal atoms in the structure. These non-bonding pairs are represented as dots and are called lone pairs. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. This process is continued until all of the remaining valence electrons have been distributed or until each terminal atom is surrounded by 4 pairs of electrons. These 4 pairs are called an octet of electrons. If any valence electrons remain, those are assigned to the central atom, even if it causes that atom to violate the octet rule. The fifth step is to determine if each atom in the structure contains an octet by counting the number of pairs associated with each atom. Each bonding pair shared between atoms are counted as a pair for each atom on the bond. In this case, the carbon atom is surrounded by 4 pairs. The carbon has an octet. Also in this case, each chlorine atom is surrounded by 4 pairs. Each chlorine atom has an octet. Since all of the atoms in this structure contain an octet, this structure is octet conforming and meets the goals of this presentation. The second example is construction of the Lewis structure of the ammonia molecule. The first step is counting the valence electrons. Being in group 15 means nitrogen donates 5 electrons to the molecule. Being in group 1 means each hydrogen donates 1 valence electron to the molecule. That gives a total of 8 valence electrons for each ammonia molecule. In the second step, hydrogen has the lowest electronegativity, but remember that in all cases hydrogen must be a terminal atom, so nitrogen must be the central atom in this molecule. The third step requires formation of a skeletal structure by bonding each terminal atom to the central atom. The bonding pairs are then subtracted from the total. The fourth step requires the remaining electrons to be distributed to the terminal atoms symmetrically in pairs, except for each hydrogen. Hydrogen can only accept 2 valence electrons, and those are already represented by the bonding pair. This is the hydrogen duet rule. Thus, the remaining electrons are placed on the central atom, which in this case is nitrogen. The fifth step requires checking each atom for an octet, or in the case of hydrogen atoms, a duet. In this case, the nitrogen is surrounded by 4 pairs of electrons. Nitrogen has an octet. Each hydrogen is surrounded by a pair of electrons. Each hydrogen has a duet. The steps required to create a simple Lewis structure that is octet conforming are: 1. Count all valence electrons in the molecule. 2. Assign the lowest electronegativity atom as the central atom, except hydrogen, which is always a terminal atom. 3. Create a skeletal structure by making a single bond between the central atom and the terminal atom. 4. Distribute any remaining electrons in pairs symmetrically to the terminal atoms other than hydrogen until each is surrounded by an octet. Any electrons remaining at this point should be placed in pairs on the central atom. 5. Check that each atom is surrounded by an octet of electrons. The next presentation will present examples of Lewis structures that violate the octet rule.